So I am going to start today's lecture. Today's lecture topic is linearly homogeneous production function. So first of all, learning outcomes. After completing this lecture, students will know about properties of linearly homogeneous production function and interpretation of its properties. So what is homogeneous function? A function is said to be homogeneous of degree r if multiplications of each of its independent variables by a constant j will alter the value of the function by the proportion j to the power r. Let a function z is a function of x1, x2 up to xn. So where x1, x2 up to xn, these are independent variables. So if we multiply these independent variables with a constant j, in this situation, if it will alter the value of the function by the proportion j to the power r, then this function is said to be homogeneous of degree r. Okay, and if the value of r is 1, in that situation it is called linearly homogeneous function. Is it clear?
Yes, ma'am.
Is it okay? So now linear homogeneous production function. So here let Q is a function of k and l, where k and l are input. These are independent variables of this production function. So Q is a function of k and l is a linearly homogeneous function that is raising all inputs. Therefore, will always raise the output exactly J4. Okay. So what does it mean? It means that the degree of homogeneity of this function is 1. Okay, because it is linearly homogeneous production function. So we have to see the properties of linearly homogeneous production function here. There are some properties. The first property is, given the linearly homogeneous production function, Q is a function of k and l, the average physical product of labor and of capital can be expressed as function of capital labor ratio. You know. So what is the average physical product of labor? How we can get average physical product of labor? Can you tell me? Tuba, are you hearing me? Tuba, that's
Yes, ma'am.
mean. Okay.
ম্যাম হচ্ছে Q by L.
Q by L. What does it mean? Q by L. That means if
Average
we, yes, average physical product of
product.
labor. Yes. That means if we divide total output by total labor, then we'll get average physical product of labor. Okay. So our production function is Q is a function of K and L. So here, if we want to get average physical product of labor, then we have to divide Q by L. Okay. So I'm sharing it whiteboard with you. Just see it. Okay. So here our function is Q is a function of K and L. Okay. So average physical product of labor equal to Q by L. So we have to divide the whole function. Q by L means K by L and L by L. Clear?
Yes, ma'am.
Okay. So function of K by L, comma 1. Is it clear?
জি ম্যাম।
Okay. So if we denote K by L as small k, then we can write it function of small k, comma 1. Okay. So so if we denote this function as y, this is also a function sign. So we can write that phi is a function of small k. Can you write this in this way?
Yes, ma'am. Yes.
Okay. Okay. That means average physical product of labor is a function of capital labor ratio. Clear?
Yes, ma'am.
Okay. Then what about average physical product of capital? So if, what is the formula of average physical product of capital?
Q by K.
Q by K. Yes. That means if we divide total output by total capital, then we'll get average physical product of capital. So here is Q by K. So we can write Q by K as Q by L into L by K. Can you write as this way?
Yes, ma'am.
Okay. So why we have to write as this way? Because we have found that Q by L. Q by L means phi of small k. Am I right? And here is
Yes.
okay. Then we can divide it as k by L. Here is this is into L by k. Okay. If we divide it, then we will get k by L. Can you write in this way?
Yeah, ma'am.
Okay. Then we can write phi of small k divided by small k. Okay, so that means here is average physical product of capital. This is also a function of capital labor ratio. Okay, is it clear?
Yes, ma'am.
Okay, so here is, that means this is also a function of capital labor ratio. So what is the interpretation of this calculation? We can say that since both average production depend on capital labor ratio alone, so linearly homogeneity implied that as long as the capital labor ratio is kept constant, the average product will be constant too. Therefore, while the production function is homogeneous of degree 1, its derived function, here is its derived functions are average physical product of labor and average physical product of capital. These are homogeneous of degree 0 in the variables capital and labor. Okay. So economically, we can say that if capital and labor are increased by the firm in the same proportion, keeping the capital labor ratio constant, then there would be absolutely no change in average physical product of labor and average physical product of capital. So as a result, the average physical product of labor and average physical product of capital are homogeneous of degree 0 in capital and labor. Clear? Is it clear to everyone?
Yes, ma'am.
Okay. So then property 2. Okay. Here is given the linearly homogeneous production function. Our given linearly homogeneous production function is Q is a function of K and L. The marginal physical products, that means marginal physical product of labor and marginal physical product of capital. These also can be expressed as function of capital labor ratio alone. Okay. So let's prove these properties. Here our general production function, our given linearly homogeneous production function K is a function of K and L. So from property 1, our property 1 was the average physical product of labor and average physical product of capital are the function of capital labor ratio. Can you remember that? Okay. So from property 1, we have average physical product of labor equal to, we found average physical product of labor Q by L equal to phi K. Phi is the function. This is a function sign. So function of capital labor ratio. So we can write this Q equal to L into function of capital labor ratio. Okay. So then to find the marginal product, we'll differentiate Q with respect to capital and labor. Okay. So MPPK, what is MPPK? MPPK means change in output with respect to change in capital. Okay. So change in output with respect to change in capital. Then we can write a delta divided delta K. Here is Q means L into function of small k. Here is Q. What does Q means? Here is Q means L into function of small k. Okay.
Okay.
Okay. So just we put the value of Q here, A into function of small k. Okay. So in this situation, we can use the the derivative formula of uv. Can you see this? Del u into v divided by del x means v del u by del x plus u del v by del x. So here is L into function of small k. We can assume L as u and phi of small k as v. So we can write in this way. So if L is u, then we have to follow this formula. So v del u by del x, that means L del phi of small k divided by del k. Okay, plus here is phi of small k means u. This means v. So the phi of small k into del L by del k. Can you write in this way? Can you?
Yes, ma'am.
Okay. So here is if we differentiate del small k with respect to del k, then we'll get the del. Sorry, here is first of all we have to differentiate del small phi of small k with respect to k capital. Okay, so here is phi of small k. Here is small k means capital lever ratio. Okay, so this is capital lever ratio. So if we differentiate this one, we can write this as phi prime of small k. Then we have to differentiate small k. Small k means capital lever ratio. Okay, so we have already find out the value of differentiated value of capital lever ratio here with respect to capital K. This one is uh, 1 by L. Can you see this? 1 by L. So Tasmin, Toyoba, then Sadia, is it
Yes,
clear?
ma'am. Yes,
Abdi
ma'am.
Karim Dawood?
Yes, ma'am.
Okay. So this is 1 by L here, and here is this is a partial differentiation. We are differentiating it with respect to K, and that is why in this situation, yeah, in this specific calculation, L is constant, and that is why it term would become 0. So this term, this full term would become 0. So only we can write L phi prime of small k into 1 by L. That is phi prime of small k. So okay, I'm sharing a whiteboard, and you can see this one, this calculation there. Okay, so here is del q divided by del k. Del q divided by del k means m p p k. Is it right? M p p k means del q divided by del k.
Yes,
Del
ma'am.
q divided by del k. Okay, del q divided by del k. Okay. So differentiate. So from APPL we get that APPL equal to APPL equal to Q by L. Okay, and from here we got this means phi of small k. Okay, so from here we can write Q equal to L into phi of small k. Clear? L into phi of small k. So we have to put the value of q here. We have to put the value of q equal to L into phi of small k here. Okay. So if we put the value of q here, then that means del L into phi of small k. Okay. Del phi of small k divided by del k. Is it clear? Then we have to use the students. Are you hearing me?
Yes, ma'am.
Okay. So we can write here phi of small k, that is mu, del L divided by del k, then plus L into del phi of small k divided by del k. Can you write in this way?
Yes, ma'am.
Okay. So here is phi of small k, phi of small k into, this is a partial differentiation and we are differentiating with respect to k. So for this specific calculation, L is constant and that is why del L divided by del k will become 0. It would become 0. Okay. So into 0. Okay. Plus here is L into, we have to differentiate phi of small k first. So phi of small k, we can write it as phi prime of small k. Then we have to differentiate small k, del small k divided by del k. Is this clear? Toyoba, Tasmin, Dawood.
Yes, ma'am.
Yes, ma'am.
Okay. So phi of small k into 0 means 0 plus L into phi prime of small k. Here is del k means del k by L. Okay. Divided by del capital K. Okay. So we can write L into phi prime of small k. Then here is k by, we will differentiate k by L with respect to k. So can you tell me what is the differentiation value of del k by L divided by del k? What is the differentiation value of this term? Can you tell me? Toiba, Tasmin, here is 1 by L is the coefficient of k. Are you hearing me?
Ji, ma'am.
Okay.
Yes, ma'am.
So here is 1 by L is the coefficient of k. Okay. So what is the differentiation value of this term? What is the differentiation value of k by L with respect to k? Can you tell me? Tasmin, Toyoba, Dawood, or anyone? Yusuf. Can you tell me what is the differentiation value of k by L with respect to k? Toyoba. So here is 1 by L is the coefficient of k. So according to rules of differentiation, we know that if the differentiation of coefficient of variable will be unchanged. So here is this, the differentiation value of this term is only 1 by L. 1 by L. Toba, Tasmin, Dawood, then Yusuf.
Ji, ma'am.
Is it
Ji,
clear or
ma'am.
not?
Ji,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So 1 by L. Why it is 1 by L? Because here is 1 by L is the, here is 1 by L is the coefficient of capital. Coefficient of capital. Okay. We are differentiating with respect to k. So here is according to rule of according to differentiation rules, we know that the differentiation of coefficient of any variable will be unchanged, and that is why here is coefficient is 1 by L, so it would become unchanged. Okay. So that means you can write here phi prime of small k. Clear? So phi prime of small k means
Yes.
it means that marginal physical product of capital is a function of capital lever ratio. This is a function of capital lever ratio.
Ratio.
So what about the marginal physical product of capital? What about the marginal physical product of capital? Do you know the formula of marginal physical product of capital? So I'm hearing another boot here. That is del Q divided by
Del K.
marginal physical product of capital means del Q divided by del K, but marginal physical product of labor means
Del Q by del L.
del Q by del L. That means change in total output with respect to change in labor. Okay. So marginal physical product of labor means del Q divided by del L. So Q means L into phi of small k. Okay. Here is Q means L into phi of small k divided by del L. Okay. So we have to apply the UV formula of differentiation. So here is what is the UV formula? Tasmin or Tayeba? Anyone can tell me what is the differentiation CB? How we can proceed it? Tasmin, Tayeba, Dawood.
জি
Then
ম্যাম কোন ফর্মুলাটা?
how we can
ইউ
proceed it here? Del a differentiation of L into phi of small k with respect to L. Okay. So we can write here L, then del phi of small k. Can you write in this way?
ইয়েস ম্যাম।
জি ম্যাম।
Okay. Then divided by del L, then plus what?
del
Then
plus
this
k
response. Okay. Then plus
k
where is k? The phi of small k. Okay.
5
Yes, phi of small k into what? Into del L by del L.
del by del L.
Is it clear or not?
জি ম্যাম।
Yes, ma'am, it's clear.
If it is clear, then why you are not interested to respond? So here is L into del phi of small k divided by del L plus phi of small k into del L by del L. Just we are using the UV formula here is just we use here del U into V divided by del X equal to V, okay, V into del U divided by del X plus X into del V divided by del X. Okay. By
Yes.
using this formula, here is del U divided by del X. Just I'm writing the second term here. It's not a matter. Sorry, here is U. Okay. So U. So here is L into phi of small k. Okay. You can denote it as U, it as V. Okay, or it as U, it as V. It's your choice. So L into here is if you denote L as U. Okay, L as U. Then here is U into del V by del X. This is plus, so no problem which term you will write earlier. It's not a problem. If you write this term earlier, it's not problem. If you write this term earlier, this is also not a problem. Okay, so here is L into del phi divided by del L plus phi of small k into del L by del L. Okay, so whatever this one, here is this is L into del phi of small k, divided by del L plus phi of small k. Here is del L by del L means differentiation of L with respect to L.
1
It is 1. Okay. So we can write is phi of small k plus L into here is del phi of small k divided by del L. We have to differentiate phi of small k first, then we can write phi prime of small k. Okay, then we have to differentiate del small k. That means capital lever ratio with respect to k. Here this term is clear or not?
Yes ma'am.
ইয়েস ম্যাম।
Okay, so sorry, here is this one still here not Listen, we are differentiating with respect to L. Okay. So del K divided by del L. Okay. So we can write here. I am erasing this term. So first find out the value of del small k divided by del L. Here is del small k divided by del L. What does it mean? It means that del capital lever ratio divided by del L. Okay. So if we differentiate it with respect to L, then we have to use this formula, del U divided by V, okay, divided by del X. Okay. So what is this formula? Here is K means U, L means V, and here is we are differentiating it with respect to L, but here we will differentiate it with respect to X. Clear?
Yes, ma'am.
Yes,
Okay.
ma'am.
What is the formula of this one? What is the formula of this differentiation? Differentiation of U by V. Here is V
Mm,
square, then
V
V
into
V into del
del U by del X
del U by del X, then
minus
minus
U into
U into
del V by del X.
del V by del X. Yes. Okay. So we have to use this formula to calculate this one. Okay. So here is K means U, L means V. Okay. So then you have to tell me how we can write this formula. Where is so here is so we have to divide it by divided by what? L. Tell me.
L square
L square. Okay. Then here is
K
L into
of
L
L
into yes L into
del K
del K. Yes. Del K by
del L
del L. Yes. Then minus
minus K
K
del L
del L divided by
del
del
L.
L. Yes. Okay. So here is del K divided by del L. We are differentiating with respect to L here. So here is K is constant. For this specific calculation, K is constant because this is partial differentiation and we are differentiating with respect to L. Okay. So this term would become what would be the value of this term? Del small del K divided by del L. It will be the value del K divided by del L. It would become 0 because this is partial differentiation and we are differentiating with respect to L, and that is why K is constant for this specific calculation. Is it clear to everyone?
Yes, ma'am.
yes,
Okay.
ma'am.
So we can write here L into 0. L into 0 minus K into del L by del L means 1. Okay. So this one. So that means here is del small k divided by del L means minus k by L square. Okay. Just we have to put the value del small k divided by del L here. Okay. So this was Martian physical product of lever. Martian physical product of lever. So we will put the we will substitute the value of del small k divided by del L here. Okay. So just you have to remember this one. I am using this. This is minus k by L square. Del small k divided by del L means uh, minus k by L square. Okay. So our marginal physical product of lever is phi of small k plus L into phi prime of phi prime of small k into del small k divided by del L. Okay. Now put the value here. Here is just erasing this one. Here is phi of small k plus L into, tell me, just you have to respond. Okay. L phi prime of small k into what is the value of del small k divided by del L? What is the value of del small k divided by del L? तो अब तस्मी आपदी कोई
minus k by L.
minus k by L or L square?
L square. L square.
K by L square, yes. Minus k by L square. Okay. So into minus k by L square. L square. Okay. Just we will write this clearly here. Phi of small k plus L phi prime of small k. Okay. Okay. Then minus into plus. Plus into minus is, it will become minus. Okay. Minus. So minus L into phi prime of small k into k by L square. K by L square. Can you write in this way?
Yes, ma'am.
Okay. So here's phi of small k minus, here is L square, here is L. So we can eliminate one L from here. Okay. L, and here is L square. So we can write k by only L. K by L. So phi prime of small k into k by L. Is it clear?
Yes, ma'am.
Okay. So I'm erasing these terms. So from here, this means marginal physical product of labor. Okay. So we got marginal physical product of labor equal to phi of small k means capital labor ratio minus phi prime of small k means capital labor ratio. Here is also capital labor ratio. This is capital labor ratio. So we can write this just like MPPL equal phi of small k minus phi prime of small k into small k into small k. Okay, sorry. Okay, into small k. So that means here marginal physical product of labor, marginal physical product of labor is a function of, here is small k. Marginal physical product of labor. Are you hearing me, students? Are you
Yes,
hearing
ma'am.
me?
Yes, ma'am.
Okay. So here is marginal physical product of labor is the function of, here is small k, that means capital labor ratio. Here is small k capital labor ratio. Here is also small k capital labor ratio. So we can conclude that marginal physical product of labor is also a function of capital labor ratio. Can it conclude in this way?
Yes, ma'am.
Okay. So what does it mean? So it means we have found that marginal physical product of labor is a function of capital labor ratio, as well as marginal physical product of labor is a function of capital labor. So we can conclude in this way that if capital and labor are increased by the firm in the same proportion, keeping the capital labor ratio constant, then there would be absolutely no change in marginal physical product of labor and marginal physical product of capital. Okay, and the marginal physical product of labor and marginal physical product of capital functions are homogeneous of degree 0. That means just like average physical product of labor and average physical product of capital. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so I'm going to stop the share here. Okay, then so here is we have already showed the calculation. Here is MPPK 5 prime of small k, and how we get MPPL equal to this one. That means marginal physical product of labor and marginal physical product of capital. Both are function of capital labor ratio. Okay. So the third property of linearly homogeneous production function. The third property is the linearly homogeneous production function satisfies the Euler's theorem. So first of all, we have to know what is Euler's theorem. Okay, so Euler's theorem means if we consider a function z is a function of x and y, if we consider this function's degree of homogeneity is r, then Euler's theorem states that the sum of the product of each independent variable by its first derivative with respect to that variable will be equivalently equal to the value of that function times the degree of homogeneity. That means here it means that the product of each of independent variables. Here is independent variables are x and y. So product of each independent variable by its first derivative means x into del z by del x. First derivative of z with respect to x is del z divided by del x. So x into del z by del x. Then we have to sum it with the independent variable y, with the product value of independent variable y and its first derivative. First derivative means first derivative of z with respect to y. That means x into del z by del x plus y into del z by del y. It would become equivalently equal to the value of the function. So value of the function is z, value of the function times the degree of homogeneity. Here this function's degree of homogeneity is r. That means we have to that means here is this term will become exactly same as r into z. Is it clear to everyone? Here is
Ye-
here is the independent variables are x and y, okay. So
Ex-
the product of each independent variable by its first partial derivative. So product here is independent variable x into first partial derivative with respect to x is del z divided by del x plus another independent variable is y. So y into first partial derivative of z with respect to y is del z divided by del y. So product of each independent variable with their first partial derivative, okay, is x into del z by del x and y into del z by del y. Then we have to sum this. That means x into del z by del x plus y into del z by del y. It would become equivalently equal the value of the function. The value of the function is z times the degree of homogeneity. Here degree of homogeneity is r, so r into z. Clear? So we have to prove this for our linearly homogeneous production function. Our linearly homogeneous production function q is a function of k and l. So according to Euler's theorem, here is x means k. Am I right?
Yes, ma'am.
Okay, x means k, then del z means q. So del z divided by del x means del q divided by del k. Then we have to sum. Here is plus sign. Then y means l. So l into del q divided by del l equal to our given production functions degree of homogeneity is r is what? Degree of homogeneity of q is a function of k and l in our lecture. Okay, what is the degree of homogeneity? Can you tell me what is the degree of homogeneity of Q is a function of K and L? Toyoba,
0.
Tasmin, degree of homogeneity is 0. Linearly homogeneous. We are
1, ma'am.
Madam, it's
linearly
1.
homogeneous production function. Okay, so degree of homogeneity is 1. So we have to put the value of R equal to 1 here, and here is instead of Z, we have to put the value here Q, because our function is Q. Clear? Is this one is clear or not?
Yes, ma'am, it's clear.
Okay, thank you. Then
Yeah.
we have to prove that the we have to prove that the linearly homogeneous production function satisfies Euler's theorem. That means left side equal to right. So we have to prove this. So here is left side is k into del q divided by del k plus l into del q divided by del l. Okay. So we have to put the value del q divided by del k. We have already calculated this one. We have already calculated this one. So del q divided by del k means 5 prime of small k. 5 prime of small k.
Right.
Me students. So here is k into del q by del k plus l into del q by del l. So here we are just substituting the value of del q by del k here and del q by del l here. Here is just we are substituting this value. Here is MPPL means this one. MPPL means del q by del l. So you have to substitute this value in Euler's theorem left side, and we have to substitute MPPK means del Q by del K. Okay, we have to substitute this value in Euler's theorem left side. Clear, students? Is it clear? Toyoba, Tasmin, then
Yes, ma'am.
Yusuf,
Yes, ma'am.
are you hearing me? Okay, so here is we are just substituting the values of del q by del k and del q by del l here. Okay, by calculating this, we got that it is exactly q. It is exactly q. So what does it mean? It means economically this property means that under condition of constant returns to scale, because this is a linearly homogeneous production function, that means this production function shows the constant returns to scale. Okay, if each input factor is paid the amount of its marginal product, each input, okay, each input is paid the amount of its marginal product. Huh. Then total product will be exactly adjusted. So if you give payment capital same as its marginal product, and if you give labor the payment same as its marginal product, then the total product Q will be totally distributed among the factors of production. Okay, totally, and that is why it is called that the total product will be exactly adjusted by the distributed shares for all input factors. Okay, or we can say it equivalently, the economic profit will be 0. The economic profit will be 0. Is it clear to everyone or not? Is there any
Yes,
question?
yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, then Toyba, Tasmin, Dawood, Yusuf. Okay, do you have any question?
No, ma'am.
No question. Okay,
No.
so can you tell me what is the average physical product of labor? What is the degree of homogeneity of average physical product of labor and average physical product of capital? Degree of homogeneity of APPL and
Ma'am,
APPK.
1.
One degree of homogeneity, average physical product of labor 1, or the our main production functions degree of homogeneity 1.
Madam, our main production of homogeneous is 1.
Yes, yes, Q, the linearly homogeneous production function degree of homogeneity is 1. But what about the average physical product, average physical products, and marginal physical products degree of homogeneity? These are 0.
Madam, is 0. Maybe it's 0.
Yes, these are 0. Just we have already proved this here.
All right.
We have already proved this here. In this interpretation, we can see this here. So do you have any question on this lecture? Students, is it clear to you? Just
Yes,
tell me.
ma'am.
It's
Yes,
clear.
ma'am.
Yes, yes,
So
madam. It's
if
clear.
it is clear, then why you cannot give answer that the what is the degree of homogeneity of average physical products and marginal physical products? Okay. So inshallah, in the next class, we'll start the constant elasticity of substitution function. Already, I have provided this lecture sheet to you 2 days before. So now I think it is clear. If it is not clear, you have to practice more because there are some mathematical terms. You have to practice more. If you face any kind of problem, okay, if you cannot understand any term, okay, or if you face any kind of problems, then you will inform me in the next class. Okay.
Okay, ma'am.
Inshallah.
Okay. So thank you so much. Allah Hafiz.
Okay, thank you
Assalamu
so
alaikum.
much, madam.
Ma'am, assalamu
Yes,
alaikum.
yes, yes.
Madam, next class will be on Saturday, right? Next Saturday,
Next Saturday. Yes,
because
yes,
of next Friday we will be holding in public holiday, right?
yes. Government holiday. Okay. Yes,
Okay.
yes, yes. Okay. Allah Hafiz.
Okay. Allah Hafiz. Assalamu alaikum.
Okay, ma'am.
Wa
Assalamu
alaikum
alaikum.
assalam.